Bismillah ar-Rahman Rahim. So let us start our module 10. In this module, we will be designing the structure slabs as per ACI 31814. So before going to the different section of the code, let me show you the ramp. We have modeled the ramp, but no one has remind me that we haven't assigned the thickness to the ramp or loads to the ramp. So I have assigned the thickness to the ramp is 9 inches. This is also based on the thickness of the slab, a minimum thickness of the slab as per the one-way slabs. And we have assigned the ramp thickness is 9 inches, and the load we have assigned to the ramp is 60 as live load and 50 as SDL. So this was a bit small portion that we forget to assign these. So I have assigned these in the Etab model. So let us again move towards the presentation. For the design of the ramps and the slabs as per the code, there is a limitation on the minimum reinforcement for the two-way slabs, or this is also for the one-way slabs in the table 8.6.1.1, and this is the AS minimum for non-pre-stressed two-way slabs, and this limitation is also applicable for the one-way slab as well. And it says that if you are using the defound bars, and if Fy is less than 60,000, then this equation is applicable, which is 0.002 Ag. And if the Fy is equal to or greater than 60,000, then greater of these two will be applicable. So in our case, we are using grade 616, so we will use this second one, and this is 0.0018 into 60,000 divided by Fy into Ag. So if you insert these values, 0.0018 into 60 into 6.5, that will be the thickness of the slab, and to convert the feet into inches, the multiplication is to 12, so we have to multiply with 12 so in order to get the reinforcement in inch square per foot. So this 60 will cancel each other, and you will get the value of 0.1404 inch square per foot. And from this it is number 3 at the rate 9 inches centimeter. This is the minimum reinforcement. And from the second, if you multiply 0.0014 into 12 into 6.5, and it will give you 0.11 inch square per foot. So this value is greater than, so it says that you have to select the greater value of these two. So this is the governing value. So if the software is, the reinforcement is less than 0.1404, so you must provide number 3 at the rate 9 inches centimeter. We will see in a while. Let us go to the Etab. In the Etab, you can check the reinforcement in the Etab as well, or you can import and export the values to the safe as well, right? So I have already run the analysis in the Etab. Let me show you quickly. You have to go to the design, concrete slab design, and you have to click on this start design. So it will start designing your slab. So I have already designed that in the Etab because we will be interested in the safe software. Click on the display flexure design, and this window will appear. Select the finite element base and click on apply, and it will show you the contours of the reinforcement, but it does not show any clear contours in the Etab. So that's why the safe is the special software developed by the CSI for the design of the safe slabs and the foundations. So what is the procedure for this? You have to go to the file, click on the export, and click on the story as safe version 12 or and above, and you have to click on this, and then you have to select the story you want to export to the safe. You want to export story 11, 12, 10, for example. Select a story, click on the second option, export floor loads and loads from the above, and then select all the load cases, select all load combos. If you want to select a specific, for example, the combos that we have defined, you have to select those 9 combos, click OK, and click OK. It will ask you to save that file. Then you have to save, for example, save file and save. So it will save that file in that folder, and then you have to go to the save and click on the file, then click on the import save f2k file, and you can see that this is the file, save file that we have exported, and click OK, open. So the story that you have wanted to export to the safe, it has been successfully exported to the safe. The next is that you have to select the design code. For example, go to the design preferences, select the code you want to design the slab, and then the minimum cover, which is 0.75 for the slabs. The preferred bar that you will be using is, for example, number 4, and this is for the strip methods, leave it as it is. And then you have to select the minimum reinforcement criteria, whether it is one-way slab or two-way slab. Then you can select that from here, click OK, and the next would be that you click on the run button, and it will start running and designing the analysis. This is the thing you have to do in the safe, because you have exported the loads, the properties, everything you have exported from the Etab. So after the analysis, the software will show you this window. It will show you the deform shape for the displacements, and after that you have to go to the display, click on the show slab design, and let's uncheck this, click on apply. You can see the contours that shows by the E tab, the safe. And if I click on the, this is the middle portion of the slab. If I click, keep moving the cursor, it shows the reinforcement is 0.000778 inch square per foot, and it is 0.08 inch square per foot, and in here it is 0.04, which is less than the minimum defined by the code. So if I click on the impose minimum reinforcement and click on apply, so you can see that minimum reinforcement has been imposed by the software. It says the same value 0.04104 inch square per foot that we have calculated manually from the design code, because the software has used the same equations that we used in here. So this is the direction 1, which is the in x direction, and the next is direction 2. This is the direction 2 bottom rebars, and click on apply again. It will pass on the minimum. It is 0.0. It is 0.1404 inch square per foot. These are the contours range. You can play with it. For example, 0. Let me show the reinforcement from arranging from 0.01 to 0.2. So it will change the contours for you, right? And similarly for the top, this is the top in the x direction, and you can see it has imposed the minimum reinforcement 0.1404. In the next direction, direction 2, again the reinforcement is a bit higher when you move towards the column, and it says again majority is, it is 0.15, 0.16, 0.0, it is again minimum. So what is the procedure that you know You calculate this number 3 at the rate 9 inches centimeter. This is the minimum that you must provide. So we will check that whether if you provide number 3 at the rate 6 inches centimeter, it will work or not. So this is the tab, the show rebar above specified value. Click on the typical uniform reinforcement specified below. For the bottom, select number 3 and the spacing is 9 inches. So I am telling the software that if I provide number 3 at the rate 9 inches center, will I need more reinforcement or not? Well, this will be enough. So if I click OK, so now it shows 0 contours, and if I move the cursor over it, so it says 0 inch square per foot. It means if you provide, this is actually top, bottom, this is the it is written in here that the bottom intensity inch square per foot in direction 1 addition to number 3 at the rate 9 inches centimeter. So so it shows 0.0261 inch square per foot in these panels in direction 1 addition to number 3 at the 9 inch centimeter. So if I decrease the spacing to 8 inches, so the contours are a bit decreased, and then if I make it 7, so you can see the contours has been disappeared in both the direction, in direction 1 and direction 2. But we will use numbers 3 at the rate 6 in centimeter, but most of the contractors will not be it's a psychological fact that you are using number 3 bar, so you can use number 4 bar. For example, number 4 bar at the rate, let us check for 12 inches. So it is working in number 4 at the rate 12 inches in the center as well. In 10 inches also, for example, you make it 24. So it's not working at number 4 at the rate 24 inches center. But the maximum spacing for this is 6.5 times 2. It is 13 inches. So you can provide maximum 13 inches spacing if you use number 4 bar. This is the maximum limit in the code, which we will see in a while. Right? So we will use number 3 bar at the rate 6 center for the bottom. You can see in both of the direction, 0 reinforcement is required when you provide number 3 bar at the rate 6 inches 100%. So from the Etabs results, the safe results, the bottom was 0.13, which was working with the number 3 at the rate 10 and 9 center, but we will use number 3 at the rate 6 inches center as our final reinforcement. From the ETAP it was 0.404, which is equal to the minimum. For the top, let us move to the top. For the top, for example, if I use number 3 at the rate 12 inches center, will it work? It says no, because the digital contours are appeared in direction 1 as well as in direction 2. So if I keep on decreasing the spacing, let's make it 10. So the contours, if some of the contours have disappeared or have been lightened, if I make it 9, so the contours has been disappeared. Some of the contours are here. Let us make it 8. Let us make it 7. It has been disappeared. So number 3 at the rate 7 is working both for the top and bottom, but again we will use number 3 at the rate 6 inches center. These are the very minimum reinforcement. If you click on it, 0.0066. If you calculate the spacing required, For example, 0.0066. If I use number 3 bar divided by 0.0066, and if I multiply with 12 to convert it inches, so you need number 3 bar at the rate 200 inches center to center for this, which is ignorable. You can ignore that, but we are using at 6 inches. So if I click, it will also disappear, right? So for the top, again, the minimum is adopted by the software, or it was 0.1505, but we are using number 3 bar at the rate 6 inches center to center, or you can use number 4 bar at the rate 10 inches center to center. So this is the final results. If someone is thinking about the punching, so there is no punching issue in this slab, because we have beams all over the columns. If you want to check it, you can check it out using going to the display. Click on the show punching shear design, and it says NC, which is not calculated because you have beam over the columns. So when you have beam over the column, there would be no punching issue. The next is the ramp, which I have explained that, but the ramp cannot be exported to the safe because it is the inclined element, and safe cannot deal with the inclined elements. So you have to design that in the Etabs. So we have to select the ramp only, click on the slab section, ramp 9, and click show undefined shape, show selected object only. So we have the ramp is only visible. So I have already run the analysis or design of the slabs. So you have to go to the display design. The procedure is same. You have to just click on the start design, or you can check it out the design combos, which we have included, or the software is included. You can check it out that as well. You can also select the design code. This is ACI 3.18.14. The same procedure which we have followed in the safe. Click on the design, concrete slab design. Click on the display feature design. This is the same window, and let us reinforcement that it says 0.03 inch square per foot, which is the unit is written in here in the top. If I click on the imposed minimum, it says 0.17, 0.11, because the thickness of this ramp is different from the typical slab. So this is the direction 1 and that is direction 2. Similarly for the top, the reinforcement would be maximum at the edges and minimum at the middle portion of the slab. Similarly the direction 2 top, and it says the contours are very unusual or very different, just because this structure is inclined, and we have applied different loads, for example the gravity loads as well as the earthquake loads. So the contours are very different from the typical slab contours. So we will check the reinforcement. For example, if we use number 3 bar at the rate 6 inches center to center, so it's working, right? But we will use number 4 bar at the rate 8 inches center to center for the top. You can see that. Similarly for the, actually the top is number 3 at the rate 6 inches center to center. So you can see if you provide, you can use number 3 bar, but it's actually a ramp, and the minimum reinforcement would be greater than that of the typical slab, because the thickness of the slab was 6.5 and the thickness of the ramp is 9 inches. So you can calculate the minimum reinforcement by just multiplying the, for example, 0.0018 into 9 into 12. So the minimum is 0.944. We can make it 0.2. So zero point 0.2 divided by zero point 0.2, that would be 1 if you multiply with 12. So you need number 4 at the rate 12 inches standard center as minimum reinforcement for the ramp. But we will use number 4 at the rate 8 inches standard center for the bottom, and for the top we will use number 4 at the rate 6 inches. There are different factors, momentary distributions for the concrete, long-term and short-term deflections, for the improper, not quality control at the side, because if you provide number 4 at the rate 8 inches, so the steel fixers, if they give the spacing at the rate 9 or 10, so you will be on the safe side. So for the bottom we will be using number 4 at the rate 8, and for the top we will be using number 4 at the rate 6 inches center to center. The next is there is also a maximum spacing for the reinforcement for two slabs, and it says in the 8.7.22 that for the non-pre-stressed solid slabs, the maximum spacing for the deformed longitudinal reinforcement shall be lesser of 2h. H is the thickness of the slab, and 18 inches. And the next is at the critical section, and the lesser of 3h and 18 inches in other sections. But we will follow 2h and 18 inches in all these sections. And if you multiply 2 with 6.5, just for the typical slab, it says that 13 inches in the center, and the next is 18 inches. This is for the typical slab. The next is ramp. If you multiply it with the 9 inches, so it will give you a value of 18 inches, and the next is 18 inches. So this was the whole story for the maximum spacing of reinforcement for the slabs. So now if you have any questions, you can ask.